recording. Great. Okay. Welcome, everyone. My name is Ryan Schlater. I'm the Communications Director for the Climate Center. We are a climate and energy policy nonprofit working to rapidly reduce climate pollution at scale, starting in California. And I'm very glad to have this wonderful group of experts here with us today. We're a fairly small group, so this can be a pretty interactive session. We'll have our four panelists give short presentations, and then we'll have the majority of the hour for Q&A. For the folks who have joined, if at any point you would like to drop a question in the chat, please feel free to do that. And then once everybody has given their remarks, invite you to come off mute and ask questions. We'll have plenty of time for dialogue. I will do my best to keep an eye on the questions that come in on the chat, but if I miss one, please just drop it in there again and we'll make sure we get to answer everything that you need. And once again, this is being recorded. We'll send it out within a few days. And so with that, I am pleased to hand it over to our first presenter, who is Dr. Catherine White from the Central Valley Air Quality Coalition.
Thank you, Ryan, and thanks to the Climate Center team for setting up this opportunity and you all for participating. I have just a few slides and I'm going to need to move my Zoom stuff around so that I can display this. So as Ryan said, my name is Dr. Catherine White. I use they and she pronouns, and I'm the executive director for the Central Valley Air Quality Coalition, or CVAC for short. CVAC has existed for almost 20 years now, unified in our mission to restore clean air to the San Joaquin Valley, which is the most polluted air basin for fine particles and one of the most polluted for ozone. To be clear on my expertise and my specialization, I do have a PhD in geography, and I'm a generalist in California geography, community development, environmental justice, community organizing, and social movement building. I am not a geologist by training or an expert in carbon capture and storage. CVAC as a coalition has gotten engaged in these issues because our local environmental justice organizations and partners started coming to us over the last few years to get more information about what is carbon capture and storage. And we have several projects proposed locally that people are concerned and trying to gain more information about. So that has been our entryway into this work. So what is carbon capture and storage? Carbon can be stored naturally through processes like composting, urban forestry, and wetland restoration. The San Joaquin Valley used to have many more wetlands and riparian habitats that have been converted for uses like farming and housing. Some land, especially in priority areas, could be converted back and have multiple benefits like flood control and creation of wildlife habitat. Our forests, if properly managed, could also naturally store carbon. Unfortunately, we all know wildfires are releasing a lot of carbon into the atmosphere and are getting worse with rising temperatures and exacerbating our air pollution and climate challenges. So one method being proposed that's of great concern to environmental justice communities is engineered carbon capture and storage, or CCS for short. CCS is a method that removes carbon at the source of power plants and industrial smokestacks, oftentimes compressing it and then injecting it underground in pockets normally filled with either saline water or oil and gas in them. Every part of the process, from capture to transport if needed through trucks and pipelines and storage, all pose risks. Based on its geology and history of oil and gas drilling, the San Joaquin Valley as a region has been identified as one of the most promising areas for carbon storage in California. CCS proponents argue that it is a quote unquote clean technology that will help us solve our climate change and air pollution challenges, but CCS is expensive and has not been proven to be effective. We have multiple proposals in the San Joaquin Valley for storage, including in the San Joaquin Sacramento River Delta region, which is an incredibly sensitive and valuable ecosystem. There are also several idle biomass plants, namely in Mendota and Delano, that are being proposed to be brought back online and have CCS attached to them, and an active biomass plant in South Stockton. And each of those plants are in environmental justice communities. So that's a particular form of carbon capture and storage attached to bioenergy. So those biomass plants are investments from Chevron and Clean Energy Systems. claiming that bringing biomass plants back online is going to help stop the open burning of agricultural waste. But California already requires an end to open agricultural burning in the valley by 2025. And instead of burning agricultural waste, it should be chipped and added to the soil, composted, or mulched. These solutions would revitalize soil health and increase crop yields. Even if companies are able to capture some of the CO2, there are still going to be harmful air pollutants associated with these projects, like particulate matter, which is incredibly dangerous to people's health, coming from things like the truck traffic and facility operations associated with the CCS project and the potential for malfunctions. Studies show that cutting forests and using trees for biomass electricity doesn't work to protect communities from wildfires, and it's an incredibly expensive form of energy generation. And again, those resources could arguably be better spent elsewhere. So the map here depicts the potential for carbon storage throughout the region, connected by pipelines. And on the right, what you see are photos, the top one being the idle biomass plant in Delano that they're proposing to bring back online that had a lot of violations when it was in operation. The majority of the carbon recovered in CCS has been used by oil companies for enhanced oil recovery, or what's referred to as EOR, which generates more unhealthy air, the potential for oil spills, water contamination, and is not a climate solution because it perpetuates the use of fossil fuels. They're proposing 100+ years of storage underground, which can increase the risks of groundwater contamination, the potential that earthquakes could be triggered, and the potential for leaks that can lead to suffocation and death of nearby residents. There was a recent incident in Louisiana where there were some pretty horrifying and rapid experiences that community members had. San Joaquin Valley communities and local economies that have relied on burning and mining fossil fuels, which generates a lot of air and climate pollution, can switch from an extraction-based economy to healthy, safe jobs that pay a living wage and generate clean, renewable energy. There are ample opportunities in ecosystem restoration, plugging idle and abandoned wells, working in education, climate resilience, emergency preparedness, and caregiving are all sectors where we need more investments. So my last slide, in conclusion, it's really important that we keep in mind the unequal health and social costs of climate change. We all know that average temperatures are going up and that the planet is warming, that the United States is a major emitter of greenhouse gases, and that within the United States and globally, it's the wealthiest people that are producing the most emissions, but it's the poorest people who are bearing the brunt of the costs. In the San Joaquin Valley, we're one of the poorest and most polluted places in the United States. And we've essentially been told in order for CCS to be cost effective, we need to put it on existing infrastructure, which means continuing to concentrate pollution in our most impacted communities. Under climate change, we are already facing more extreme heat days, catastrophic wildfires, and worsening air pollution. So while California is positioning itself as a leader on climate and is now claiming to care about equity, we need to ensure that the solutions translate on the ground and provide direct benefits for our environmental justice communities. Climate justice to me means that as we adapt to a warming planet, which is caused by humans burning fossil fuels, that we ensure that Black and Indigenous peoples and people of color, low-income communities, and other historically disenfranchised groups are prioritized. We need to invest in direct emissions reductions. We can't always buy or build our way out of a problem. At ecosystem restoration, community resilience, and doing less of the activities that cause the pollution are the types of investments that we at CVAC are interested in. So that concludes my overview. And with that, I'm going to pass it back to Ryan.
Thank you so much. And I am going to go ahead and pass it directly to Dr. Chelsea Carey from Point Blue Conservation Science. Chelsea, take it away.
Excellent. Thank you so much. I'm going to go ahead and share my screen here. And all right, can you all see my PowerPoint? Yes, great. Okay.
Yes.
Awesome. So hi, everyone. Thanks so much for organizing this event and for inviting me. I'm looking forward to building on what Catherine has already shared. So my name is Chelsea Carey. I serve as the Working Lands Research Director and a Principal Soil Ecologist at Point Blue Conservation Science. We're a nonprofit based just north of San Francisco in Petaluma. And we've been around for about 50 years, conducting ecological monitoring to inform conservation action. And nowadays we focus generally on climate smart conservation, so building in adaptation and resilience into our landscapes and helping to mitigate greenhouse gas emissions where possible. I have a background in soil microbial ecology and biogeochemistry, and I help to lead a lot of our work on carbon stewardship on working lands in California specifically. So today I'm going to share a little bit about why land-based stewardship is such an important natural climate solution, and I will touch on some of the science that specifically supports intentions to protect and rebuild soil carbon as part of that solution. So I wanted to start sort of high level, and when we think about the land base or in the agricultural land in particular, as a natural climate solution, carbon is central to the story. And so carbon, of course, is the basic building block of life. It makes up about half of all that is living, and it can be found in different, what we call pools or reservoirs. And these are things like the ocean or soil or the air, and it moves between these pools through natural and man-made processes. So in the air, carbon is primarily carbon dioxide. It's a greenhouse gas, meaning it traps and re-radiates heat and energy coming from the Earth's surface, and it contributes to the greenhouse effect. And it's important to note that greenhouse gases like CO2 are actually extremely important. Without them, the average temperature of the Earth's surface would be 33 degrees Celsius lower than it is today, and that would essentially render our planet effectively unlivable. But human activities have increased the amount of CO2, of course, in the atmosphere over time and other greenhouse gases, and this contributes to global climate change. And this can be seen in the graph on the top left here. There are a number of activities that contribute to this, including burning of fossil fuels, so from industry, for example, but also land use change and soil degradation have contributed to this rise over the past 12,000 years via land conversion and mismanagement. And so in this time, soils have lost as much carbon to the atmosphere as has been lost from vegetation through global deforestation. And this trend can be seen in this bottom graph depicting land and agriculture, and then the associated cumulative soil carbon loss, which are the yellow dots over time. The amount that's been lost is really nothing to sneeze at, and it suggests that, to me, that stewardship of our landscapes is really an important part of the climate stewardship picture. So loss of carbon from the land to the air, particularly from soils, it has repercussions that go beyond contributing to climate change. It affects the ability of the land to continue providing healthy and abundant food, especially in the face of things like droughts and floods and other stressors that result from climate change. So in other words, a loss of soil carbon, it reduces climate resiliency at the very same time that climate resilience is becoming more and more necessary. And so carbon loss from soils, it also has negative impacts on the ability of land to capture and store and purify water, and can lead to issues with soil erosion and ultimately environmental sustainability. But we're in luck because terrestrial landscapes, including agricultural lands, they have these built-in carbon capture systems. And scientists agree that we need to re-energize and restore this system to at least some degree through stewardship, and that we can do that. Doing that will help to draw down carbon dioxide from the atmosphere and put it back into the land. And this can help mitigate climate change, but also, again, rebuild resiliency and environmental sustainability. And we know, of course, that cutting emissions is so important. It's central to the story, but so is drawing down carbon dioxide from the atmosphere. And here in the land base, we have an opportunity to work with the land to help do just that. So farmers and ranchers have well-founded principles that are based in science, that are demonstrated across the globe, that they can lean on to help effectively steward carbon. And these include principles like keeping the soil covered, reducing soil disturbance, increasing the amount and diversity of plants and plant residues that enter the soil, And at the same time, there is a disagreement among scientists about, or debate about, how much of the lost soil carbon can be recouped through this kind of stewardship. And estimates range from anywhere between 8 petagrams of carbon to 88 petagrams of carbon as a total potential, which is equivalent to about 29 to 322 gigatons of CO2. And that's a big range, and it depends primarily on presumed social, ecological, and technical constraints at the global scale, and less on the global, what we call the biophysical potential of soils. Sorry, there we go. Okay, let me see. Okay. So what's actually possible is probably somewhere in the middle, and work by Bronson Griscom and more recently Deb Bossio at the Nature Conservancy and colleagues, they evaluated 20 land stewardship actions, including the ones that you see here, and found a mitigation potential globally of up to around 24 gigatons of CO2 equivalent per year. And 25% of that is coming from protecting and rebuilding soil carbon globally. And I really like this figure from Deb Bossio and her colleagues that show what it shows is the annual maximum potential of climate mitigation that includes safeguards, so constraints that are applied to make sure that we keep an eye on human needs for food, fiber, and fuel in 2030. And I like it because it shows the mitigation potential of these various stewardship actions, but it also highlights how much of the action is cost effective. And so the cost effective portion of the bars here is where it's less than $100 US dollars per ton of CO2 equivalent per year. And then the low cost is less than 10 US dollars. And I also like that it explicitly shows the expected co-benefits of these actions. So those colored bars that are in between the sort of words and then the mitigation potential highlight the benefits to air and biodiversity, water and food, and show them the multifaceted importance of these natural climate solutions to help achieve desirable outcomes that are beyond just climate change mitigation. Sorry, my computer is being just a little bit slow. Okay. The importance of land-based carbon stewardship, it holds in California. So I was showing just some graphs that we're looking at it globally. Now let's move sort of more regionally. And one can make the argument that given the political and programmatic structures that are already in place or are emerging in the state, that California is really poised to lead the way in this space. But a question that is critical and sits front and center in many people's minds is sort of what's possible. Well, there was a study published in 2017 that highlighted the importance of ecosystem management and land conversion to help achieve the state's climate goals. And the authors then found that protection and stewardship could contribute 12% of the climate reductions needed to get us 40% below 1990 levels by 2030. And this number is likely conservative because the stewardship actions that were considered didn't include the full suite of tools that exist and are being leveraged, particularly on working lands today. And so there's a lot more in our toolbox that we can sort of pull out and lean on to help achieve our climate change mitigation goals. Now, a key to unlocking that potential is mobilizing at scale across the state's natural and working lands. If that doesn't happen, then I just want to quote Stan et al. 2018 that the potential opportunities for soil carbon management to contribute meaningfully to California's climate mitigation goals, it will be very modest at best. So we need to do this at scale. And as we work to coordinate action across the state, as a scientist, when I reflect on sort of how this should roll out, I have 3 recommendations that come to my mind. And the first is really we need to focus on prioritizing sites carefully. So focusing on those sites that currently have high amounts of carbon to protect them, keep that carbon there, or sites that we know have lost a lot of carbon where we want to rebuild through stewardship. And this is important for a number of reasons, but one that is perhaps less obvious is that for rangelands in particular, low soil carbon can actually be characteristic of an ecosystem like a serpentine grassland, which is really special in a lot of other ways. It houses a lot of native biodiversity. And it would come with trade-offs, probably undesirable trade-offs if it were to be managed solely for maximizing carbon. So there is an aspect of sort of understanding the landscape and prioritizing sites accordingly. The second recommendation I have is that we really need to determine appropriate actions. So management actions, think back to that toolbox, and there's a lot of management actions in there that we can rely on. They have different characteristics, and some may be more appropriate for one context than another. And just an example I like to go to is that planting oak trees, this may be best done in fields where there are not high densities of grassland breeding birds, because those grassland breeding birds would be disgruntled at the change in habitat, right? So just being really strategic in what management actions we put on the ground and where. And then finally, I do think that continued data collection is imperative. So we should act, but we should also be learning over time. And so continued data collection can help to refine estimates of practice impact and help us better understand what practices we can rely on and even where we should prioritize action. And I think if we do this, it will help us to realize that potential of soil carbon stewardship in California and do so in a way that maximizes co-benefits and minimizes any trade-offs. And so I will end it there and pass it back to you, Ryan. And thank you so much.
Thank you very much, Dr. Carey. I did want to note, we are going to make these slides available along with the recording. We will send those to you within the next few days. And with that, I'm going to pass it on to our next presenter, who is Lori Wayburn from the Pacific Forest Trust. And Erin, part of her remarks should get at the question that you asked in the chat. And if it doesn't, we will circle back in detail. So over to you.
Thanks. And thanks so much for including us in this briefing. I am not going to use any PowerPoint slides. I'm just going to talk. So I'm Lori Wayburn. I'm the co-founder and president of the Pacific Forest Trust. And the mission of the Pacific Forest Trust is to restore and conserve America's forests for all the benefits that they provide, and very specifically for those benefits that are irreplaceable: climate benefits, water benefits, biodiversity benefits, and really using timber harvest as a tool to support those things. So flipping the management paradigm of forests from one of timber commodities to focusing in on the forest. So putting the forest back in forestry and using timber harvest as a tool and a complementary to supporting forests for their watershed, climate, and biodiversity values as well. Pacific Forest Trust is about 30 years old. I've personally been involved in global climate change issues since the beginning of Pacific Forest Trust. I think the important thing in looking at CCS is that we cannot solve the climate crisis by one tool alone. And CCS may well be a technology that could be useful. It doesn't exist today in any scalable form. It's very expensive, and it's going to be 10 to several decades away before it will be deployable at scale. And we need to act now. We need to act now, not just in terms of carbon sequestration, but in terms of adaptation and resilience. And as our previous speakers have said, we are seeing the effects of climate change now. And if we wait until CCS is available, we simply have no shot at changing the picture and the trajectory. This was actually brought home at the Glasgow Conference of the Parties. Dealing with the climate crisis has to be done in a way that addresses adaptation and resilience, both in terms of biodiversity and in terms of human populations. So tying into what Catherine was saying earlier, there are issues of economic justice that are also part of this as well. The great thing is that natural climate solutions address all three issues, actually all four issues, of direct carbon capture and sequestration with freeware, the freely available technology of photosynthesis, adaptation, promoting the resilience of our systems directly, in dealing with the climate crises that we see, whether they are of uncharacteristic fire or the floods that we had back. We kind of are wishful for floods today, perhaps, but the floods in terms of the Oroville Dam, those are things that when we have uncharacteristic precipitation events happen, we need to moderate those. And very importantly, the biodiversity crisis. Broad acknowledgement that the loss of 1 million species is what is facing us, and that is directly tied to the degradation and loss of our natural systems. I'm going to focus in particularly on forests because those are 85% of the terrestrial carbon in California. And as Chelsea said, it's important to look at the priority actions that we can take now to address the issues now. She also pointed to the fact that forest loss and degradation is actually the second largest cause of CO2 emissions that are human caused. And so when we address forests, we are addressing direct emissions from forest loss, and roughly 2/3 of what is in a forest is lost in the near term to CO2 through timber harvest, with 1/3 remaining. So that's a big loss, but also the soil disturbance that's associated with that, as well as with agriculture, leads to CO2 loss as well. So when we address forests, we're addressing direct emissions as well as the potential to increase sequestration. I mentioned that 85% of California's terrestrial carbon is in forests already. It's important to recognize that is only a fraction of what those forests can naturally hold and did hold at the time of the arrival of Europeans in California. So these forests today hold from 10 to 50% of what they naturally can hold. So you can see a tie here between the actions of restoring our more natural forests, which means managing them, and restoring their resilience, restoring their habitat values, and restoring their carbon richness. And we can do that in this next 8 years. To do that, we do need to make it a budget priority. One of the points that we want to pull out here is that there are a number of policy priorities that are linked to action on climate change. 30 by 30, the climate smart land strategy, California's water priorities, and the natural and working lands portion of the scoping plan update are just 4 of them. Another one is, of course, to promote rural economic sustainability. So the question was posed, how much should the governor be putting into California's budget on an annual basis? And I would say very conservatively, $5 billion a year. And frankly, that's cheap, because what will you get for $5 billion a year? Let's take an example. California's water, as most of you know, comes from a relatively small area of the state. It's all in Northern California. It's all forested watersheds. It's the Northern Sierra wrapping around to Mount Shasta and down through the Trinities and Marbles, roughly a 7 million acre area. It's all mixed conifer forest. That's the headwaters for the Sacramento and the San Joaquin. The Sacramento is the backbone of that. If we were to invest in the restoration of those forests, which means conserving them as forests so we don't continue to break up that ecosystem and fragment it, and then restoring the more natural forest that will help us store more water as well as more carbon, we would do that in a way that actually paid back that $5 billion, because we would be employing more people. And studies that we have known have shown that that would be roughly 6,500 new jobs a year. That's huge in rural California. Those dollars recirculate in those communities, which have some of the highest unemployment in the nation. So we would be bringing back a more natural forest with carbon richness. We would be restoring watersheds for the backbone of our water supply. That's 85% or so of the freshwater San Francisco Bay. And it's the large majority of utilized water for both urban populations and agriculture, particularly prime irrigated agricultural lands in the state. So it's really important for multiple reasons there in adaptation. As we look at this ongoing drought, we would also be improving our fire resilience. And so Catherine mentioned that the kind of fire that we are seeing today has such negative impacts on human health, and that's absolutely true. But fire is part of our system, and restoring good fire to our systems, which is another piece of the policy picture here. So flipping the paradigm from just suppression to active fire management. As they say, learning how to dance with fire as opposed to just fleeing from it or trying to fight it is a really important step here. That actually is not, good fire is not a driver of carbon loss. It's actually a help in terms of carbon sequestration. And I'm happy to answer questions on the new science that is out there about the impact of fire on forests and how the difference between more naturally managed forests with bigger, older trees that store more carbon respond to fire as opposed to crowded young forests that we have created over these past decades. So what I'd like to suggest we keep in mind is that we are capable of walking, talking, chewing gum all at the same time in fighting the climate crisis. And it may well be that CCS is one tool within that. That would be just doing the walking or the talking or the chewing gum. We want to have, if you will, the Leatherman approach, the all tools approach. And that is what natural climate solutions, both for agricultural lands, rangelands, and forest lands, will give us the Leatherman approach to addressing the climate crisis. So from a priority perspective, where we should be putting our time, attention, money, and targeting is really on the natural climate solutions that are freely available to everybody in this state. They're not proprietary technologies, and they are not limited technologies. They're multi-purpose green technologies that anybody can use. And I think that Chelsea pointed out that our ability to meet our carbon goals within the California context will only be realized if we significantly ramp up what we're doing in the natural climate space. I'll stop there.
Thank you so much. I'm going to hand it over to my colleague Jock from the Climate Center for one final point on new legislation related to everything we've been talking about, and then we will open this up for questions. So again, feel free to pop questions into the chat, or once Jock has gone, feel free to come off mute and we can open this up for dialogue. Jock, take it away.
Thanks, Ryan. I'm just going to keep this brief in the interest of time, but in light of the conversation we've been having today about CCS, about natural approaches to carbon sequestration, the Climate Center is advancing a bill this year in the legislature. It's AB 2649 that's aiming to be a critical part of this conversation. This bill would set a target on natural and working lands to sequester 60 million metric tons by 2030, ramping up to 75 by 2035. And our thinking behind this bill is that over the last year, we produced research that shows that the working lands potential for carbon sequestration is even higher than that. And when you incorporate natural lands as well, California's lands can really sequester a huge amount of carbon. And so we want to set a target that catalyzes action and that moves the state in this direction more robustly. Additionally, as we all probably know, CCS is having a moment and it's being discussed in various venues. There are a few CCS bills in the legislature this year. And I think there needs to be a counterpoint to the CCS narrative that it's the best way to remove carbon or reduce carbon emissions. As Catherine and Lori spoke to very well, it is problematic to rely on it, and it causes environmental justice issues and exacerbates them as well. So the current state of this bill is we have a few partners that are interested in co-sponsoring and several more that are supporters. It's hopefully going to be moved to the first committee within the next few weeks here, and we're hopeful that it will advance forward after that. Thanks.
Thank you, Jock. Okay, so first, I want to circle back to Aaron's question about the level of investment needed and both open that up to any of our other speakers today, and make sure, Aaron, if you wanted to follow up on any piece of that question, you get the chance. And yeah, we can open it up from here.
Yeah, thanks. I'll take a stab. And I'm not prepared to comment on how much the state should be investing, but I will say in terms of sort of where I would like to see that funding go is to support the full suite of actions that contribute to adaptive management on working lands in particular. And this includes everything from planning through implementation and monitoring. And so I think that some of these pieces are rolling out and being supported in various ways right now, which is really exciting to see. And I would just like to see those components continue to be supported, because to have effective action, I believe you need good planning. You need the appropriate funding for technical service, but also the right amount of money going into, supporting the actual implementation of the practices. And then, of course, monitoring and verification so that we make sure that we're getting where we need to be through this stewardship.
Great. And Lori, I see your hand up. Please go for it.
I would just add to that climate change is really forcing us to rethink our basic paradigms. And we have taken nature for free. We've taken it for granted that it would function. And the paradigm of how we manage resources is that land is always going to be there and it's always going to function. And in the same way that we need to transform how we manage energy and how we manage transportation, we need to transform how we manage land. And so in addition to what Chelsea was saying, we need to make sure that we have the land base that actually can do that sequestration in a resilient and durable way. So that means in our programs that we roll out, and this goes to the question also about the $5 billion, we want to transform our approach to conservation and management. And we want to link and integrate between our actions so that we do conservation and we link it with restoration. We do restoration and we link it with conservation so that we get to the end that we want to get to, which is a carbon-rich, climate-resilient landscape. And when you think that at 85% of our terrestrial carbon is 10 to at most 50% of what these systems can hold, you realize the scale of potential that we have, because we literally have released billions of tons of CO2 from our forests in terms of how we have managed them. So we want to transform how we think about these issues, and not in silos, like we do one thing at a time.
Thanks. I'm going to go to Martin, and then Aaron will get to the question that you just put in the chat. After that, Martin, please go for it.
This is Martin Wiskel. I'm a reporter for the Orange County Register in the Southern California newspaper group. I have 3 questions I'm hoping I can address before we finish here. One of them is down here in Southern California, there's a company called AES that recently constructed new gas-fired power generators at plants in Huntington Beach and in Long Beach. And it touts those as being cleaner and more efficient. I don't think there's any argument that they're more efficient than 40-year-old, 50-year-old generators that they replace. But they also say that they're capturing more of the emissions before they reach the atmosphere. And I'm not that well versed in this. I'm wondering if, when they say that, if that is related at all to CCS. What they seem to be implying is that they're putting less carbon into the air. Is that something anybody here has the knowledge to address? Whether the new generators are emitting less carbon? Okay, that sounds like a negative.
I'll make a note of that, and I'll see if we can track down an answer for you, though.
Okay. And the second thing was that in the Climate Center's report titled Setting an Ambitious Sequestration Goal for California's Working Lands from January 2022, 2 of the biggest areas for potential natural carbon capture are pasture compost and cropland compost. Jock and I spoke a little bit about this yesterday, but I didn't, in the 40-minute presentations that you guys gave, I don't think I heard compost mentioned once, even though these are at the top of the list in this study. Does everybody agree that pasture compost and cropland compost does hold the most potential for carbon capture? Or is this just a climate center position? And then the second question on that is, where is all of this compost going to come from? And how is this compost going to capture carbon from the atmosphere? So I guess there's three questions. First of all,
Thanks, Martin.
does everybody agree that pasture compost and cropland compost are two of the highest potential areas for carbon capture?
I want to clarify just quickly that our report does focus on working lands, and a lot of the discussion we're having now is natural and working lands. So there might be additional solutions that have greater or more potential when you incorporate that. But so I just wanted to clarify that, and then I'll turn it over to Lori and Chelsea for more.
Yeah, I'll take a stab at answering part of that. So I would say that the potential for compost to be a part of the solution and sequester carbon most effectively out of sort of the suite of tools that we have on rangelands and croplands, I would say that is the general consensus within California. And there's one of the studies that I referenced by Charlotte Stanton was actually an expert elicitation on soil carbon in California and how we can manage it on cropland and rangeland. And by far, hands down, compost was reviewed as sort of having the most potential in addition to biochar, but biochar is has even more challenges from a scaling perspective right now. In terms of the I'm not sure. I am not a compost expert myself. I am not sure of all, sort of all of the solutions to providing the necessary compost to meet these goals. Maybe others on this call have more thoughts on that in terms of how it can actually increase carbon. So the idea there is that as you're adding compost, that's organic matter, of course, you'll be adding the carbon into the soil with that compost. But the idea is that that's actually going to boost the system to capture more carbon than it otherwise would through increased plant production. And the mechanism there is that the organic matter you're applying, it comes with nutrients and it can hold water. And both nutrients and water are limiting to plant growth. So if you add that to the soil, conceivably you will be improving plant growth, which will help to sequester carbon, all else equal. So that's really the primary mechanism for why compost should help to add additional carbon gains to the system.
Okay, and Jock, maybe you, if nobody else, can follow up on. We talked a little bit about this yesterday, but this seems like an awful lot of compost we're talking about if we're going to capture the millions of metric tons through composting. Where is all this composting coming from?
Yeah, I can take a stab at that. So in our report, we do refer to the a Lawrence Livermore laboratory report called Getting to Neutral that estimates that the amount of biomass produced in the state per year is around 54 million metric tons. And that could be turned into around 20 million metric tons of compost. So that's actually plenty. That should be enough to meet these goals. So that can come from various sources, but the amount of feedstock, I would say, is probably not the limiting factor.
Okay, so we're talking about landscape waste, food waste, agricultural waste.
Correct. Yeah.
And you're saying that there's 54 million metric tons that are not being used for compost that could be used for compost?
I believe that is how the Lawrence Livermore report frames it. Yes.
Okay.
Yeah.
And just my last question, at least at this stage, there seems to be a distinction, and correct me if I'm wrong, between direct air capture and smokestack capture. From what I've read, and again, I'm new to this, that smokestack capture can be done within the factory. Maybe, I don't know the exact technology, maybe it's within the stack itself, but before it enters the atmosphere, as opposed to direct air capture, which is capturing it once it's in the atmosphere. And so my first question is that an accurate understanding? And second, if that is so, it would seem as though smokestack capture is a lot closer to being realized than direct air capture. Is my understanding correct on those 2 points?
So we have a response in the chat on the first point. Yes, you are correct on the distinction between the two. Would anybody like to speak to the which is closer to deployment? We heard a little bit about this, but perhaps either Dr. Catherine White or Laura, you could expand on that.
No, my hand was raised more regarding Martin's earlier question, and just that the Climate Center's report was focusing in on rangelands and agricultural lands. So it was not meant to be something that was, these are the only places that you would do sequestration. Forests are going to be absolutely a key driver here in terms of meeting these goals. But the composting is actually now going to be more feasible, because as you will all note, there is a bill that mandates composting by 2025. So the amount of material that will be available from food waste and urban waste is going to increase dramatically, requiring composting in all of our communities across the state. So just in terms of availability of feedstock, that's going to ramp up hugely. Secondly, forests are obviously going to have to be absolutely core to this. They have more potential than any other sector, but it's not this isn't a game between, I don't mean the word game, but it's not a competition between who's best. We need to do it all, frankly. And just to underscore what Chelsea was saying, the mechanism here is that the drivers of sequestration are the plants and the trees. You know, in terms of this, trees grow from the air. They absorb the CO2 from the air. They are direct capture, and they put it down into their bodies and into the soil. So composting rebuilds the soil, which enables the plants to grow more effectively and store more water. So it's really, it's a really multifaceted technology, and it's known, it's free, it's deployable now.
And
Great, so
another aspect there too to the compost is the avoided emissions. So it is diverting waste from landfills as well, and that's a big piece of this picture too.
Right, reducing emissions from that, which is really critical.
Yeah, and I was just going to tag on both of the 2 points. I also am not an expert in what has the most potential to sequester carbon, but we do have a lot of ag waste in the San Joaquin Valley, and we do have really negative health impacts from open agricultural burning. And I did mention in my presentation that we are very much in support, and there's a lot of research showing that adding ag woody waste to the soil, composting it and mulching it is climate resilient. It's cost effective for the farmers if we can actually get them to transition over to those practices. And also fundamentally that the scale of agriculture and the system of agriculture in the San Joaquin Valley is fundamentally not sustainable. So if we're going to be sustainable in the long term, we have to figure out a way to scale our activities so that the waste that we're generating can be incorporated into the local ecosystems, or we're going to perpetuate a system where waste is generated in a place and then has to be trucked long distance. often into our EJ communities and burned, which is exactly what's happening right now and why we're so concerned about these bioenergy, biomass, carbon capture and sequestration proposals. Because again, it's a way of perpetuating bad, dirty, harmful practices instead of finding new things. I'm also not super expert in direct air capture versus CCS, but from some of the background reading that I was doing, my understanding is CCS is further along technologically than direct air capture, and that particularly there's a focus on retrofitting existing kind of infrastructure versus developing new facilities. First of all, because it's cheaper to retrofit existing infrastructure. And again, because typically there are more incentives, because oftentimes those retrofits are being used for things like enhanced oil recovery, which again is going to perpetuate the life cycle of fossil fuels.
Thank you, everyone.
Great. I did want to go back to a question from Aaron in the chat to clarify. Is it correct that natural sequestration will get more difficult past 2030? Can anyone speak to that?
Actually, it's the reverse. When you look at what forests do, they will only get better after 2030. And the issue there being that older, more natural forest stands, so stands that have been thinned out to reduce the number of stems per acre, but growing older trees. This is the way to double and triple the carbon that is in the stands over time. So in fact, when we look at this and you look at the restoration of these forests while producing commodities, but reproducing, if you will, the natural stocking, the natural species and the natural age classes, this is precisely what will take off in 2035, 2040, 2050 and beyond. So the potential is actually right, we're right at the beginning of the sweet spot of that potential. These are forest types across California. All of our forest types are long-lived, and we have been managing them for very short periods of time. To give you quick examples, our redwood forests live well over 500 years, up into the 1,000 and even 2,000 years. We're managing them for 60-year rotations at best. Just a fraction of their capacity. Our mixed conifer forests, again, we're managing them at best for 60-year type rotations. They grow 200, 300 years. So by restoring that more natural, uneven age class across the landscape, it will get far better in the future. So it's just the beginning.
Thank you. Did anybody else want to speak to that question? I'm not seeing any other questions in the chat. And so if that's the case, we can bring this to a close. I want to thank everyone for their time today. I'll drop my email in the chat one more time. I believe everybody has it. Feel free to follow up with me. We will get the slides and the recording out to folks within the next couple of days. And as Jock mentioned, we are expecting the AB 2649, the bill related to what we've been talking about, to be released to the public next week. Apologies, the timing on that has changed a couple of times in the last few days. And so we'll provide more information on that. And if anybody would like to get in contact with our speakers today, please go ahead and email me, and I am happy to facilitate that. Once again, thank you all, and I hope you all have a great day.
Thanks all so much.
Thank you.
Thank you.